Binomial theorem and binomial expansions. The formula here is in the formula tables. To be able to use it, however, we would need to be able to calculate combinations using the calculator. I have 4 examples here. Written in these long brackets, 7 with a 4 underneath it. We read this as 7 combination 4 or 7C4. So on the calculator we would write down 7C4. The combinations button, we get that by pressing Shift and the division button. So 7C4 is 35. This means that there are 35 different ways we could select a group of 4 from 7 options. The next one is 6C2. This is the number of ways we could select a group of 2 from 6 choices. We see that 6C2 is 15. There are 15 different groups of 2 we could choose from a choice of 6. I'm quickly going to give the answers to the others here. We see that using the calculator, 6C4 is 15 and 15C4 is 1365. Now we've been asked to expand fully these 2 expressions. The first one is p plus q to the power of 6. We could multiply the p plus q, this binomial 2-term expression, by itself 6 times, but it's easier to use the formula. The formula says nc0, that would be 6c0, p is to the power of 6 and q is to the power of 0. There's a pattern to this, you'll notice. So the next one will be 6c1. P is reduced by 1, so it's p to the power of 5, and q is increased by 1, so it's q to the power of 1. And the pattern continues. The next one is 6c2. P is reduced by 1, so it's p to the power of 4, and q is to the power of 2. It increases by 1. And it continues like this. The next one will be 6c2. P to the power of 3. We keep reducing it by 1, and q to the power of 3. We're increasing it. The next one will be 6c4. P is to the power of 2, and q is to the power of 4. You might notice that the power of q is always the same as the number of things we're choosing. So that's something to notice in the pattern. The next one is 65. P is the power of 1 and q is the power of 5. You notice that the powers of p and q, they always add up to 6 as well. And the last one is 66. Now p has been reduced to 0 and q is the power of 6. So after a while you get used to this pattern and this becomes a little bit easier to set up. Now we'd have to use a calculator to work these out. So I'm using the calculator, working out the combinations, and this is the answers that we get. And notice too that when you expand something to the power of 6, a binomial to the power of 6, it has 7 terms in it. There's always one more term than the power in a binomial expansion. You'll also see symmetry if you look at the pattern here. Let's look at the second question. So it's the same thing we're expected to do. So in the second one we have 2x minus 3y, that's our binomial, and we're expanding this to the power of 4. Again, you could multiply this by itself 4 times, but it's easier to use the binomial expansion. So since it's the power of 4, it's going to be 4c0 first. Our 2x is going to be raised to the power of 4, and our negative 3y, the sign is important there, is raised to the power of 0. And the pattern continues. 4c1, 2x this time is to the power of 3, and a negative 3y is the same as the thing we're choosing. So that's the power of 1. Again, the powers must add up to 4 each time. 4c2, 2x to the power of 2, negative 3y to the power of 2 also. And we know there's going to be 5 terms in this expression. So keep going. The next one is 4c3. 2x is the power of 1. The negative 3y is the power of 3. And the last one then, we have 4c4. We know we're at the end when the number you're selecting from is the same as the number of things you're selecting. We have 2x to the power of 0. Anything to the power of 0 is 1. And negative 3y to the power of 4. Then we'll use the calculator to maybe evaluate each part of this. So we evaluate our combinations and our powers of numbers here. I'm just doing it quickly here. And when we tidy this up, you'll notice there's a pattern to it. So you'll notice that the first one is x to the power of 4, x to the power of 3, x to the power of 2 going down, and from the other end going up, we can see the y values doing the same.